Hello, welcome to a new week. This week you're going to cover Chapter 5 and Chapter 6. Both are different ways of using graphs than what you've seen before. These are ways that will help people optimize routes, such as people picking up trash, delivering mail, things of that sort. What I mainly want to do is go over the templates, the applets that you'll be using for a few of the problems. The rest of it you're reading in the chapters and the videos that are already assigned. So my main purpose is just show you how to use the applets. So first of all, I want to go to chapter 5 and look at number 10. So we'll go to chapter 5, Euler circuits and paths. And then we want to look at number 10, which asks you to use the applet. So this tells you that you're supposed to construct a graph with these vertices and with these edges, and you'll know what that means more as you read through the chapter. So what I want to do is I want to go to the applet that's in blue right here. And then when I go to the applet, then I'm going to go to create a graph. And then when I create the graph, what I want to do on this one is to put the edges on. So on that problem, it said to put edge AB, AD, BC, BD, CD, and CE, EF, and EG. So what I'm going to do is I'm just going to put those edges. So I click my cursor, and then when I let it up, that'll be A and B. And then it says to do an AD. So I figure C would probably be somewhere here, D somewhere here. So I'm going to put an AD. Then the next line it says, or edge, it says is BC. So I'm going to connect B to C. And then it says to put BD. Well, I figure D would be somewhere over here. So I'm going to put BD. And then I'm going to put CD. That's the next one it asked me to put. So I'm going to connect C to D. And then it says CE. So I figure A, B, C, D, E, E somewhere up in here. So I'm going to put CE. And then it asked me to put EF. So I'm going to construct an EF, figuring F might be somewhere along here. And then it says to put an EG somewhere along here. And then the question it asked me is which of these edges are bridges? And you'll understand what bridges might mean more in the chapter, but the bridges would be EC, EG, and EF. Those are the places that would cause a disconnect if you were to erase them. But again, you'll understand that more as you read through the chapter. So that's chapter 5, number 10. And then using Fleury's algorithm, it can give you some help doing that too, although doing them by hand is probably just as easy. Then the next thing I want to do is go back to chapter 6. And look at number 10, which also uses an applet. So in chapter 6, another thing, the applets are always, if you look in here under all the assignments you have in this chapter, again, these are the readings, these are the homework problems. If you see this symbol, that's where applets are. And so you could actually just click on those to get the applets, but most of the problems that expect you to use the applets also have a direct connect. So like number 10, it wants you to use the applet, and so it has a direct connect right here. It says click here to use the applet. So I'm going to click there. And also you see these distances. It gives me the edges, and it also tells me some distances because I'm going to use that in these Hamilton circuits. So I'm going to click here to use the applet and then create a graph. All right, and if you noticed back on the problem, we had 4 vertices. We had 4 places we were going to visit. So I'm going to change this to a complete 4, and you'll understand again as you go through the readings more what that stands for. So I'm going to change that to a K4, and I want to change these weights to what you saw over there. So I'm going to change the weights. And the first weight that it gave me was that AB was 5. So if I click right here on this, it'll let me change that weight to 5. And then I confirm the change. AC, from here to here, I want to change that weight to 10. AD was 1, so I can leave that alone. BC, from B to C, it said was 7. Then from B to D was 2. So I changed that up 12, I want 2. And then from C to D is 4. Okay, now it lets you calculate this using brute force, which you'll find in the readings is looking at all the possibilities, nearest neighbors, which is another method, and cheapest link. Brute force gives you the optimum. These give you good ones, don't take as long to do, but are not optimum. So in this problem, it asks you to compare optimum to nearest neighbor. So under brute force, I look at brute force, and what I want it to do is I want it to calculate all the possibilities. So the first possibility is A, B, C, D, A, and it has 17. So I want to write these numbers down because I want the lowest one. The lowest one's the optimum. So that one's 17. The second one gives me 21. The third one gives me 20. The fourth one gives me 21. The fifth one gives me 20. The sixth one gives me 17. So 17 is the optimum. Then I want to look at the same problem using the nearest neighbor technique. So with the nearest neighbor technique, what I want to do is I want to click on where I start. It tells me in the problem that I need to start at A. And so then I looked for the nearest one, 5, 10, and 1. 1 is the nearest one. So I click D, which would be the next one. And then from D, I've got 2, I've got 4. 2 is closer, so I'm going to click on the 2. So from D to B. All right, then from B, I can either go 7 or I can go 5, but 5 takes me back to A, and I don't want to go to A until I've covered all the vertices. So I'm going to click on C, and then from C, I just need to get back to A. And so we found the nearest neighbor tour, and you see the calculation, it's 20. So optimum was 17, nearest neighbor was 20, and then the textbook gives you a formula for calculating the percent error there, which is what this problem asks you to do. I hope this was helpful. Again, I'm praying that you have a blessed week and that you use your talents to honor God.